Today, we're going to discuss about differential equations, particularly the topic called degree and the order. So, what is the order of a differential equation? What is the degree of a differential equations? So, let's start with the first order of a differential equations. What do you mean by this order of a differential equations? It's very simple. It is the order of the highest order derivative in an equation. An equation is called what? It's called the order of the differential equations. Okay, so I'll give you an example. Here's an example. Let's say d square y by dx square plus 2y equal to like 5x plus 6. Okay, so it's the first example. I'll give more examples. Second, d square y by dx square plus 5 dy dx plus 6x 2y minus 2. Okay, so let's hear. So when we are looking in this particular topic, the first example, what is the order? So let's start looking from the first. How many derivative are there? How many derivative are there in these equations? We have only one. Yes, we have only one. And what is the order? Is a second derivative, right? What kind of derivative? Is a second derivative. So that means the order will be 2. 2 is the answer. So it's the second order differential equation. Okay, so what about here? How many derivative are there in the equations? How many derivative are there in these equations? We have 2 derivative. That means we have 2 derivative in these equations. And which one is the highest? Example, another one is dy by dx. These are the derivative, but which one is the highest? This one is the highest. The highest, let's look the definitions. The highest order derivative, the order of the highest derivative. The order of the highest derivative, what is this? Is the second order. So answer is this. Correct? So is the example. So I'll give you some more example. Let's say log dy by dx equal to ax plus by. So how many derivative are there here? We have only one. Then, and what is the order? Is a first order. Correct? It's very simple, right? And let's see another example. What about sine? Sine dy dx equal to x to the power 100. Here, what is the order? We have only one derivative, and order is only 1. It's the first order. Correct? So what about if I give an example? Dy by dx square k plus dy by dx to the power q whole 5 by 3. What about this? How many derivative are there? We have 2 derivative. And which one is the highest? This is the highest. So then what is the order? Is it the third order or first order or second order? We should not look this. We should go for the highest derivative. The answer is what? Is the first order. Is the second order, right? This is the answer. Okay. So it is the example of the, I've given enough examples of the order of a differential equations. So let's jump into second topic. What is the second topic? The degree of a differential equations. Okay, the degree of a differential equations. So what is the definitions? It is the degree. It's the degree that is what we can say is a power. The degree of the highest order derivative. Okay, the degree of a highest order derivative involving in a differential equations. Okay, so I'm not finishing the this definition yet. So we need to add something, that is when the derivatives are met free from radical and fractional. Only after that is called what? The degree of the differential equations. Got it? So here let's see the example. Only after that we can understand properly. What is the example? So I'll give a simple example. Let's say x dy, the x second derivative of to the power q plus y square dy by dx to the power 4 plus xy is equal to 0. So tell me what is the degree. So before we find out the degree, we should find out the order first. How many derivative are there? We have 2 derivative, and which one is highest? This one is highest. And then we find out the, let's see the definitions. We have to find out what the first highest order derivative in a differential equation. So we find out, and we have to find out what the power, or maybe the degree. Degree and power same. What is the power? 3. That means order is what? The order is 2, second order, right? And what is the degree? The power in the highest derivative, that is 3. So this is the answer. Okay, so I'll give you one more example. Let's say d square y by dx square equal to k in the bracket 1 plus dy by dx to the power 3 by 5 by 3. Got it? So then tell me what is the order? Tell me what is the order. Yes, this is the highest derivative, right? We have 2 derivative, this one and this one, and highest one is the left one, this one. The order is 2, correct? But what is the questions? What is mentioning the questions? The question said, see here, look, I'll show you something. Here it said when the derivative are made free from radical fractions, right? It can be any derivative. They're not saying highest derivative should be made from. They say that any derivative, when the derivative are made free from the radical and fractional form. So let's see. This is in the radical form. It is in the radical form. So we need to make sure that it should be free from the radical. So what we can do, I'll bring this to in this side. Okay, then what will be the whole cube, k plus dy by dx whole cube 5. Now we can find out the order also 2, and degree also what? 3, because it is the highest order, and this equation is free from radical? Yes or no? Then we find out the highest derivative and we find out the power, the degree, that is 3. Okay, so let's see an example, another example. Okay, y dy by dx equal to x plus k dy by dx. What about this? How to find out? Here also, yes, these are not in the radical form, but this one is in the what? Fractional form. Yes or no? But let's see the definition again. The derivative should be free from radical and fractional. Yes or no? This is in the fractional form. Then we need to convert into simple form. So how we can do that? Okay, so dy by dx. So let's simplify this. Can we write out in this way? Right? So here comes, it will come here, then it will become square. Yes or no? Only after this we got, now we got, the equations are free from fractional form, right? So then we can, now we can find out the order. What is the order? This one is highest. Yes, we have only one derivative, so the order is 1. And what is the degree? What is the degree? Yeah, got it. This is the answer. Okay, so I'll give you one more example. This one is important. Okay, the example that I'm going to give you is very important. Like, let's say y equal to sine dy by dx. So tell me what is the order and what is the order and what is the degree? Tell me, just think for a second. Yeah, so the order we can say is we have a derivative, right? The order is what? Yeah, only 1, because it's the highest order. So we can find out the order directly. But what about the degree? The degree is not defined. Why? I'll tell you the reasons why it's not defined. Because, so if I put sine x, okay, capital X, it can be expressed in this way: plus x to the power 5 factorial, minus x to the power 7 factorial, plus it will be goes, this function will be infinite number of term. It is not like we don't have the finite form, it is infinite form. So that means here, I'm consider x as a dy by dx. Okay, so if I put these equations, sine dy by dx, then what will be the dy by dx minus dy by dx to the power cube 3 factorial plus dy by dx to the power 5 factorial. So it will be goes, and here the same, this equation also infinite. This is also infinite term. But as to find out the degree, you want to find out the degree, right? For the degree, just the function or maybe the equations should be in the polynomial function. Means there should be a what? There should be a finite number of term. Only after that we can find out the degree. So that means, so we can conclude sine x is not equal to polynomial function. Okay, polynomial function. So the degree is what? We can say degree is not defined. Correct? So now I proved that now order is 1 but degree is not defined. Okay, so it can be for any I'll give a more example. Let's say, so for any trigonometric function, any trigonometric function like sine x, or maybe cos x, or maybe tan x, cosec x. So it can be any function of trigonometric function. So if you see this kind of any trigonometric function in an equation, in a differential equations, the degree are not defined. Okay, so it's very, very important. That's why I told you to write down properly. Okay, so these are the examples. So for today, we are going to end up this video, and the next topic we'll discuss in the next video. Okay, for now we'll finish here. Okay, thank you.